Cool, cool. Hey guys, so today is the last session for the backend uh, topics that we've been covering for the past few weeks. So before we get to it, I just want to show some updates. So if you go head over to the repo, I've added some resources for the seventh session. That was the one we had last week, where we saw how to send emails and we use NodeMailer for it. So I've put up a guide to take a look at it. If you have any doubts, feel free to reach out. And for this week, today's session, we will be taking a look at uh, how do we actually deploy our applications and where do we deploy it to, how do we deploy it, all of that we'll take a look at. And just another update to the repo, I've added this small guide on how to use the Excalibur file. It's the one we've been using for the past few weeks for all of our sessions except the last one. So to put like a very mind map way of learning things. So take a look at it. You will get an idea of how you can open it yourself, play around with it, add some of your own changes, all of this included. Learning happens best when you try to interact with the things that are present. Cool. All right. So before we actually get to this point, I just want to make a question of why. Why do we actually, need to learn how to uh, deploy your projects, how to bring it to production, all of that, right? The why is very important. So what we have been doing so far, right? We built our server in our laptop. We coded out. We saw how to accept requests, how to manipulate data in an SQL database, all of that, right? Now we ran it locally. So whenever you ran your code, you had to, like initialize the server with the app.listen to a port, and that port usually we kept it as 5000. So you'd had this URL like localhost 5000, and you could open that in your laptop and see all your changes showing in the browser, or even to your Postman client as well, where you would send the request and you get a response. But now try to take that same code, try to open it up in your phone, not the code, the URL. Put localhost 5000 in your browser URL. You'd get like it's not found, error, connection loss, something like that. Let's try it. I'm not running any server. Okay. Me not running server here and it not being shown in the phone is pretty much the same. You would get this one, error, connection refused. It's not that something's not allowing you to connect, it's that the local host for that specific port is not even running in that same network. It's a different case, when, I mean, not a different case. When you're running a React app, you have localhost 3000, right? And if you're connected in the same Wi-Fi or hotspot, you could access that in your phone as well. But you'd see that is still in your localhost. For a person who's not connected to your network, they won't be able to access it. It would give them the same exact response. Site can't be reached, connection refused, because nothing is running. Okay. So, I mean, your Chrome has a default behavior to keep trying it. So, let's just fix this. I have an app, uh, not this. Yep. It's a very simple application. I've used Express. I've used .env for the environment variables, which we saw in the last session. I've used EJS for the dynamic page rendering, and obviously the basic middlewares. So you can see after I use .env, I can use something called process.env and something called code. So this port I've mentioned it here as 5000. I can change this to 5001, 8080, 5050, anything, any open port that is available, and it would actually run. So it will take that port from your env file, and it would, actually run your application. And in the forward slash request, that is a localhost port, which is 5000, it will just render the index page. The index page is in my views folder as expected because this is the EJS convention. And it's just returning a simple HTML document, which has the heading H1 my website. Okay, so let's run this. If I head over to my package JSON, you can see there's two scripts, start, one with node and dev, one with node mod. We'll use the node mod one because we might be playing around just to be on the safe side. Okay, in game run dev. You see, server running on localhost 5000. If I go to my env, I change this to 5050, save this. Obviously, NodeMod doesn't pick up env file changes because it's only working with these specific files, JavaScript, MJS, Module.js, CJS, and JSON type of files. It's looking for changes in these type of files. So you can either stop and start this, or you can simply put RS and enter. RS stands for restart. So you can see now it's running on localhost 5050. That is not what I want right now. So for example, say, let's go to 5000, come back here and reload. Yep, perfect, perfect. So this is the exact one we are expecting. Title as my website and a heading as my website as well, right? So all works as we expect it to. Okay. Now when I go to this URL in my phone, it won't actually open up. It will give the uh, same response. Site can't be reached, connection refused. Okay. So that's the point I want to get it to. You would get the same exact thing if you try to do it. Given that you're not on the same network or your server doesn't have the capabilities to serve your devices on the same network as well. Okay. So what you need to do is we need to deploy our application, this whole Node.js code we've just written, to a place that can actually serve your website to any device out there. Okay, so just to bring it into context, let's say we take this Node.js code, we place it in a server. Okay, this is our server, and this server will run our code 24/7. And then any website out there can, I mean, any device out there can access our website. Pretty good, right? So to do this, this is what we'll be seeing in today's session. We're using a platform called render.com. Towards the end, we'll see it. It's a pretty simple process, nothing to, in fact, nothing complicated at all. You can pick it up uh, within an hour, I'd say, if you try it out yourself. Okay. So let's get to it. So when it comes to deploying your applications, there are certain, checklist of things that is recommended to do that is good before you actually deploy your application to users. You don't want a faulty application. You don't want to deploy a faulty application that your users will have difficulty using at the end of the day. So you do various checks, various testing, all of these together to make sure that your application is actually usable, it is user friendly, and it is well tested. So there are zero chances for any bugs coming, though not always true. You just want to reduce the possibility of that happening as much as you can. Cool. So if you go to the Notion page, I've actually mentioned it as resources, as a well-defined checklist that you can read. It's properly defined, okay? So take a look at it. Yeah, take a look at it. And here I just mentioned a topic. So let's just speak about like 1 or 2 points each, okay? So first one is obviously your code review and testing. You want to make sure the code that you've written or your team written is proper, the logic checks out. Not really the logic, I mean, not really the testing that you've done, through Postman. You probably want to do some testing through Jest or something. So whenever you add a new feature, suppose say you are adding a login feature, you've tested it out, it works perfectly, that's great. But now you're adding another feature on top of it, say to edit the user profile. So what you want to do is, even though you've added a new feature, you want your login feature to still work. And to do that, we have various testing procedures, right? End-to-end testing, unit testing, uh, integration testing, various types are there. So just check it out. You won't have to need them all the time, but it's usually recommended in really large scale applications. So, it saves you time, though writing tests can be a bit uh, boring. I'm not going to lie, it's a bit boring. So what you want to do is, it's a one-time job. Once you write it, it's there. So for every new feature that you add, you can test it out easily, and you don't have to worry like, hey, this is that this might fail in the future. No, absolutely not. It will work because you've already written tests for it. Okay. And the code review part. So if you're working in a team, you usually have a mix of junior, senior developers. Sometimes people who maybe done a little bit extra work done than you. and they can review your code and give you feedback like, hey, you can use this feature or this method instead of this. It would speed up your code a bit. Okay. Next thing you have is configuration management. So let's just go back to our code. Take a look at it. You have your package.json, you have your get ignore, you have your .env. All these, are part of your configuration. Example, in my package.json, the configuration here, main part are the scripts, the main, and obviously the dependencies. All these are important because it is a specific configuration for my application. It tells what is actually needed. Hey, this uh, demo application here needs these dependencies. Make sure this is installed. Run this script to install it. Okay. And then you have your env file, which gives your environment variables. So it tells you like, hey, these are part of the working environment. Make sure you take up or pick up the variables from here and use them in the code. The reason we keep in environment variables is for its safety. So make sure that it is always there, present in the code, but it should not be publicly available. Good. Then you have scalability and performance. So these are usually seen in the way you write your code or the tools that you use. Sometimes using a specific tools can create some bottlenecks that cause your application to slow down or limit how it actually performs. Okay, so scalability usually refers to how many users you can serve at the same time, how many people can use your application at the same time. All of that comes over here. And performance wise, it's basically, like how fast can your application do a specific set of things or just one thing at a time. So these things also, it depends on how you write your code. It also depends on what type of configuration you're deploying your code at. For example, in your laptop, you might have a 16 GB RAM. That was, more than enough to run an application for just you. So every time you work in localhost, it's like literal instant it's giving you a website because it's just one user and you're having a 16 GB RAM. So that makes a difference actually. Good. Then you have security. So all this authentication, authorization, JWT, cookies, all these things are code related. This is how you want to secure your application. There's something called rate limiting also. Basically, some users or some, I mean, let's just call it hackers, they just bombard your application with uh, requests again and again and again. So they hit the same point over and over again until the application resources are exhausted. That is not good, right? So we can put something called rate limiting that allows users to access your application for a set number of times for a specific duration. So example, you know you can keep a really simple this one. Suppose say I have a profile update endpoint. Uh, what I can do is I can maybe keep 15 updates for 2 minutes or something, or 15 requests. That's more specific. Okay. So suppose say I am changing my profile 16 times within the same 2 minutes. Then what the application will do is it will block my uh, IP address for say 5 to 10 minutes or something. So it's all for security's purpose, okay? Just so the resources at our end, the applications end are not overutilized. Okay, then you have backups and disaster recovery. This is all like, not necessarily on your code side, though sometimes it can be. Imagine putting a delete all from user accidentally on your production database. That's not good, right? So what will happen is this is usually on your uh, where you deploy your code, the place where you deploy code, and where your database is present. So you need to keep copies of your data. That is what backups are. So in case one server, one database fails, you have a copy of it, another to fall back on. MongoDB actually does this really well. Not only MongoDB, many other servers do as well. But MongoDB does, Atlas does it by default. So you have the something called sharding. Okay. So this, yeah, it's a method of distributing data across multiple machines. So make sure you know that your users can always rely that you can always rely on MongoDB to not lose your data at any point of time. It keeps backups. It's sharding, I guess, is distribution of data. Copy is, I think, called replica set. Okay, group MongoDB process that maintains the same. Yeah, this is the exact one we're looking for. So this sort of flows will be depending on where you're deploying your data, where you're deploying your server code. So it's this is totally a choice of platform. Then you have monitoring and logging. So if you remember in one of the previous sessions, we actually kept a very simple logger. Yeah, we made a middleware called request logger. Just consoles which endpoint was hit with which method. So this was all done in the terminal. Once it's done, it's usually lost. So what people usually do is they keep a copy of it in a separate log file. Not only this, any errors that your application faces, a log of it is kept within the app or within some database. That's up to you how you figure it out. Okay. If you want to take as an example, you have your attendance, right? So you your teacher, subject teacher keeps a track of when you are present, when you're absent. So that sort of monitoring and logging also is present here. What errors come up, uh, what endpoints were hit, who tried to make which type of request, who logged in when. All these types of data is monitored not fully for your application sake, but sometimes there can be some legal actions where you need to show, hey, this user was active during this duration. So maybe that can be used as a proof somewhere. This the top of my head. Maybe I might have watched it somewhere, but I forgot where it was from. Moving on, you have documentation. Uh, a good code is no good until you have something to learn about it. Like just reading code will take so much time. Imagine I have this code over here. Okay, this auth here. I have to read this one. Okay, it first takes the or token from the cookies. Then it verifies if it's there. If it's not there, then uh, render the error page. If it's there, verify the token. If the username is there, then okay, allow the request as throw an error. Else again throw an error if the token is not. Okay, so this took about, I mean, less than a minute, but because it was a fairly simple authentication middleware, but this is usually not the case. You have really complicated authenticated flows. So I don't want to waste my time sitting and reading all of this, right? I'd probably want some clearly return statements. So for say, let's take example for this auth middleware itself. Okay, you have, I can write it up. So this middleware takes up the auth cookie present in the request cookies, verifies it, and then allows the user to move on to the next request. I mean, the same request allows them to move on. If it's not there, then probably don't allow them, right? Or maybe I'd wanted to do it in a diagram and in a very diagrammatic way. So what I can do is like create diagrams of sorts, something like this one here. If this loads up, so this is one of my projects, that uses sort of the same flow. So I've made a very simple architecture diagram. So your documentation, can be like this, like, hey, this app uses, and the front end, it uses these tools, and the back end, it uses these tools and technologies. Then you can have an architecture explaining what exactly happens. So it's very clear here, right? Without even me going to the code, I can actually just, get a whole idea from this single picture. I have a client application, the backend, that follows something called the MVC architecture. Then my database is MongoDB. So for various requests, it it goes to the client, then it checks in the server, all of these, then it goes to the database and returns back the response as a whole flow. So that's the main point. Documentation makes things easy for you and for others who will be working in your code. Now, this application, right, it's been, I guess, 4 months since I've come back to it. And this stuff here is really going to help me out if I'm going to add some new features. Like, okay, hey, I've used JW2 here for my authentication. Sure, then maybe I can use the same code for the further new features as well, right? So these, it's added in the Notion page a bit more detail. Make sure you read through it. It's like when you start out, you won't need to cover everything, but obviously for a large project or anything really serious, if you work in a startup or an MNC, depending on where your project position is, it's good to have these flows covered. Even if you're not the team lead and you're working on a project, make sure you can see that these things are being covered in your application. All right. Next up, you have like, okay, so you've seen what is required, like what do we actually need to check before we actually deploy the code. Now, where do we actually deploy? That's the next question that should come to your mind. So you have various platforms, not the ones that I've just mentioned here, Render, DigitalOcean, AWS, Amazon Web Services, Google Cloud Platform, also known as GCP. So these are a few of the popular ones. Obviously, there are many, many more out there that offer the same services. But what I want to cover in depth is not actually the platforms here, but some key points for choosing the right platform. Not saying all platforms will be your best fit. It's based on the features that they offer and based on what you're looking for. You a platform will be compatible for your code. Okay. So here is like a simple tool. I mean, this came to mind. Know what you need before where do you get what you need. So these four key points, like overview of a platform, you need to understand what are the key features, what are the use cases, and what's the pricing. Because obviously nobody is going to host your code for free at all times, or there will usually be some restrictions on how you host your code. There'll be some limitations on how many users can access, how long will your code be running for. Okay, because in my local this code will run as long as my system is active. Once I shut down my system, the code will not be running anymore, right? The idea of keeping your code up 24/7 is that you're basically configuring someone else's server. Think of using someone else's laptop that is running 24/7, with maybe some extra capabilities, 32 GB RAM, whatever that's up to you. Okay, that depends. I mean, not up to you, basically up to the platform and what features it gives. Okay. So overview, basically you need to understand what each platform does. Example, Render is usually great for simple web services like our Node project. It is good at serving static websites. It's good for hobby projects like the one we actually do build just for the sake of learning. Okay, it does have its limitations. Like it can run only 700 hours a month with very small bandwidth. Then you have DigitalOcean, which is usually good for small to medium size companies, even startups. So DigitalOcean has like a sort of a pricing plan. Not I'm not sure if it is a pay as you go, but I remember there being pricing plans where you get specific set of feature access. Then AWS and GCP is usually preferred by enterprise companies or startups that are really scaling good. So for them, these two are a good fit because it's really easy to configure the needs that you want. The RAM, the runtime environment, the bandwidth. Actually, that actually depends on how much your uh, hardware configuration is. So it's not necessary to look at it now, but it's something you'll want to see when you're getting serious about deploying your application. Okay. And AWS and GCP are a pay-as-you-go service, so it's all depends on how much as you use, that much only you pay. So, so yeah, so just based on these use cases, you can based on these four features, just take a look. So it's actually laid out on the Notion page. The overview, what are the key features for each of these four. Obviously, there's more, so please don't restrict yourself to this. Explore out there more. Okay. So I just wanted to cover these points. Next, I just wanted to take this local host that we created into an actual deployed platform that we just spoke about is called render.com. Okay, so just a few features of Render. It's a modern cloud platform that simplifies development process because it's for beginners like us. Automatic scaling, it has free SSL configuration and a very easy setup process. Use cases suited for web application APIs and static websites. Pricing, it's very free, generous tier and with a competitive pricing for scaling. I would say uh, it would your apps generally wouldn't scale as good in render as compared to others, but it's enough to get started. Okay, so let's just sign in. You don't need to like copy your code one by one. All you need is a GitHub account and where your code actually lies. Okay. So what I'll do is I have my code here currently. Let's just take the same code. I'm not going to overcomplicate the process. Okay. I'll take I'll take everything except the node modules, create a new folder, okay, called test deployment or something. Paste them all here. Okay. Just open it up and I'll add a new script called build. Okay, it's yep, trust build and simple NPMI. So this basically tells that okay, install all the dependencies for the applications, then start the application. Okay. So think about platforms like Render, like GCP, all of these, they have a general process for you or general scripts defined where you can actually use them to it'll automatically run on their platform. So that's why we were emphasizing on the start script, then you're having the end, the test, then you're having build. Build is what we just saw now. So let's just run it. npm run build. So it'll run the npm and it'll install all the dependencies for us. Cool. So let's add one more thing. I don't want the node modules to be pushed. Okay. I'll go head over to GitHub. I will create a new repo. PB test deployment. Okay. Private sorry. And the same procedure. You guys are familiar with this. So git init, git add all. Okay, so we got one thing wrong. Uh, we have to just restart this. Node modules. Yeah, the node module actually came into this. We'll stop this over another one. Yep, the spelling was wrong. Okay, now we will click add and all. Commit and initialize. Click node and paste that link. And a simple git push dash u original name. Okay, so let's head over here. We should have the same stuff. Good. So we have the code ready. We have the scripts written. All we need to is go to render, click on new. Click on web service because we are actually deploying a service, not a static website, right? It's a Node.js code. So now that this is done, what I need to do is link to my GitHub account. Since I logged in with GitHub, my code is already here. So I can directly connect with the GitHub repo. Okay. So maybe just td test repo. Okay. Test deployment, I guess. That sounds better. Okay. You can choose which region to deploy your code at, up to you. I'm just going to keep the default settings. Main is basically which branch your code is at. Since there's only one branch, it's taken main by default. It will actually always take main by default, or whichever is your default branch in your repository. Then you have your root directory. Suppose say all my code is inside in another folder and my outside code is some other project. So in that case, I can, specify, hey, go into this folder and run the code. Then what's the runtime? Obviously, I'm running Node.js, build command. I can specify here as well. So this npm run build that will install all the dependencies because we have already written it out over here, right? Just npm I, simple. I can put that here also, but it's better to keep your common build command because later you might add some other stuff as well. Then your startup code, so node index or this, or just put npm start. Okay, so obviously default options over here. Since it's a free package, we are using something called a shared CPU. So in a single server system, it will not only be your code running, it will be, other people in the same free tier, their code also running in the same CPU. Okay. Other than that, advanced is like environment variables. We do have an environment variable, but we don't actually need it to add it here because things like port, node env, all these sort of envs are default in your node environment. So the port assigned by the platform is what is actually used in the deployment. We can assign the port here, but it won't pick it up. It will throw an error. So we can skip this part totally and just create. Obviously, what they're doing is cloning it from their end to that server. Then it's going to clone, then it's going to run npm install, then only it's going to run the code. So this will take about 2 minutes. So let's just wait for this to happen. Oh, okay, that was fairly quick. Usually it takes more time. Okay. Okay, that was really good. Let's just wait for it. You see, we get a link also over here that we can use. TD test reference, that was the name of the project. And on render.com, you can assign your own domain also, up to you. But for now, this is all we need. So you can see how it's taken from your local host to an actual deployed platform, right? So now that everything is, it's saying it's built, it's run, we also saw the service running. Let's put it, and boom, perfect. So this is the exact flow we're looking for. So it was as simple as that, right? I mean, I guess it just took hardly less than 5 minutes. So here's a link. Do give it a shot. It's not too hard. I'd say you guys can try it out for yourself. And for this week's task, probably it is, create a full circle platform of that student management system where you actually integrated with an SQL database. You can use the one offered by Render itself. They have an option for Postgres. Okay. You can do this and get the configuration. You don't need much actually. This is more than enough for just for learning sake. So SQL queries remain the same. The connection also remains the same. You don't need to worry about it much. Okay. And yeah, so for this week's task, we'll just build that whole student management system, the creating account, the logging in, the adding a new student, viewing all students, editing and deleting a student, and obviously pages for it. So not all people will know how to send, get, post, delete requests, right? So page, basically a UI for users to work with. and deploy it on random. Okay, as simple as that. Please feel free to reach out to me if you have any doubts. Good, good, good. Yeah, that was it for it, guys. So, hope you got to learn something new. If anything, my chats are always open. You can always reach out to me on Twitter also. Okay, cool. Thanks, guys.